Now example 1.13. Say, an early model for an atom considered it to have a positively charged point nucleus of charge Ze, surrounded by a uniform density of negative charge up to a radius capital R. The atom as a whole is neutral. For this model, what is the electric field at a distance R from the nucleus? Now see here. In this given atomic model, the total amount of positive charge, that is Ze, which one is at the center? Then total amount of negative charge, that is minus Ze, because it is given to you. This atom is as a whole electrically neutral. And this negative charge is uniformly distributed over this radius R. It implies that here we can write this total charge, that is total volume into volume charge density. Volume charge density of negative charge, that is the charge per unit volume. So charge per unit volume is rho, therefore charge in volume 4 by 3 pi r cube is how much? So you will get that minus Ze equal to 4 by 3 pi r cube rho. Now let's consider first the field at any point inside the atom. It implies that consider the point which one is situated at distance small r from the center of the atom, where small r is less than capital R. Now consider the Gaussian surface, that is a spherical one with radius equal to small r. Now flux passing through that particular spherical Gaussian surface, that is sigma E dot delta S equal to Q upon epsilon 0. Now electric field E will be same one at each and every point on the Gaussian surface as per spherical symmetry. So E into sigma delta S, that is 4 pi r square, equal to Q upon epsilon 0. But Q, that is the charge enclosed by this Gaussian surface, it is how much? That we have to calculate first separately. Now net charge enclosed by the Gaussian surface. So see, this entire positive charge is inside the surface, but inside the surface negative charge, that is only we have to consider which is inside this one. So Q, that is positive charge Ze plus negative charge, that is 4 by 3 pi r cube rho. Now here rho, that is minus Ze upon 4 by 3 pi r cube. So this Ze as it is, 4 by 3 pi r cube as it is, and now your rho, that is replaced by minus Ze upon 4 by 3 pi r cube. So resultantly we will get this 4 by 3 pi cancelled, and we'll get Q, that is equal to, take Ze common, so 1 minus small r cube upon capital R cube. Substitute this value of Q in this equation. So E into 4 pi r square equal to 1 upon epsilon 0 into Ze into 1 minus small r cube upon capital R cube. Therefore E equal to, take this 4 pi r square on right hand side, so Ze upon 4 pi epsilon 0 r square into 1 minus r cube upon r cube. Therefore E equal to Ze upon 4 pi epsilon 0, take this r square inside the bracket, so 1 upon r square minus small r upon capital R cube. This is the electric field at any point inside the atom which one is situated at distance small r from the center of the atom. Now consider the point which is outside the atom. So field at any point outside the atom. So again, for that we can consider the Gaussian surface, which is spherical one having radius equal to r dash. But here when r dash is greater than r, entire charge of the atom, that is enclosed by this particular Gaussian surface. So atom as a whole is electrically neutral. Okay. So net charge enclosed by this particular Gaussian surface is 0. So when Q equal to 0, the net electric field, that will be also 0. It implies that outside the atom at any point, the electric field, that is 0. Clear to all of you?